Sunspot 4493 is rapidly emerging on the sun. It's in a hyperactive state, crackling and popping with magnetic tension, which tells us that powerful, high-energy X-class solar flares are now highly probable. This 3D model shows Earth, the Sun, and Jupiter aligning directly on the ecliptic plane. This rare planetary geometry, known as a Jupiter cazimi, can cause changes to the solar interior, pushing that highly volatile flux out toward Earth. Right in the middle of this activity, SpaceX is launching 20 V3 Starlink satellites. These are massive, next-generation units, putting roughly 100,000 pounds of heavy hardware directly into this highly charged space environment. If a major solar storm hits while those new satellites are deploying, it charges the atmosphere, causing it to swell. That atmospheric drag increases instantly, which would cause these giant satellites to fail their orbital checks, fall back down, and completely disintegrate. When 100,000 pounds of space junk vaporizes at once, it deposits metallic oxides directly into the mesosphere, a delicate layer of the upper atmosphere. We are injecting industrial mass into this zone at a rate far outpacing natural meteor dust. Human orbital infrastructure is actively colliding with cosmic volatility, creating severe risks for Earth's upper atmosphere. But this threat doesn't stay confined to the edges of space. The intense energy from a charged ionosphere connects directly down into the troposphere, the lowest layer where our weather happens, and it is already wreaking havoc on the ground. To stay informed on this multi-front assault from space to the surface, hit subscribe right now. Looking at the United States, this map shows a powerful upper-level trough diving down into the Midwest. This creates a highly volatile wind shear environment, meaning the winds are rapidly changing speed and direction at different altitudes. That shear is spinning up discrete supercells, capable of dropping giant destructive hail across Iowa, Wisconsin, and Illinois, covering properties in heavy ice. If these supercells form along leftover boundaries, the lingering storm fronts from morning rain, the atmosphere holds enough rotational energy to produce violent, long-track tornadoes. The system expands eastward tomorrow. It brings the threat of 70-mile-per-hour damaging wind gusts sweeping into the Ohio Valley and the Northeast, which can easily strip the walls right off a house. This specific collision of atmospheric forces takes typical summer storms and turns them into deadly, high-impact regional emergencies. Down in the Gulf of Mexico, a newly forming tropical depression is actively threatening the southern coast. This model plots the first scenario. The system tracks north, crashing into New Orleans or Mobile as a moderate tropical storm. But curving westward over open water, it gathers immense thermal energy, intensifying into a hurricane before striking Texas. This is where the incoming solar plasma plays a role. Surges of charged particles in the upper atmosphere alter electrical currents that connect down to the storm systems below, potentially fueling unpredictable, rapid cyclonic intensification. By combining the extreme warmth of the Gulf waters with this charged atmospheric environment, the storm becomes a highly volatile wildcard that could easily escalate beyond current model predictions. We are seeing these extremes trigger simultaneously worldwide. In central Chile, relentless heavy rain has caused catastrophic flooding, burying streets in thick mud and displacing hundreds of residents. Across the Atlantic, Europe is experiencing a sudden massive atmospheric cooldown after a record heat wave. The sharp temperature drop is throwing the atmosphere into chaos, triggering severe thunderstorms and also localized flooding. In India, a red alert monsoon crisis is washing away infrastructure. The mountain slopes are so thoroughly saturated that they are giving way, causing deadly landslides under intense rain rates. Meanwhile, a strengthening El Niño pattern is baking East Africa and Oceania, driving extreme heat and severe drought conditions that leave soil parched and shattered. Global weather is no longer operating in isolated pockets. Entire continents are simultaneously experiencing the absolute violent ends of the atmospheric spectrum. Earth is not a closed environmental loop. We are deeply tethered to the volatile physics of our solar system. This diagram illustrates exactly how high-speed solar wind crunches our magnetosphere. That impact cascades energy downward, transferring charge from the plasmasphere all the way down into the lithosphere, the solid rock crust of the planet. Researchers are investigating how strong telluric currents pulled through the ionosphere by solar flux might interact with crust minerals via the reverse piezoelectric mechanism. This mechanism could theoretically provide the final mechanical trigger for already stressed fault lines, necessitating a watch for high-magnitude earthquakes during periods of extreme solar loading. With solar eruptions inbound, falling satellite debris overhead, and severe terrestrial storms pounding the surface, the physical hazards are stacking up. As cosmic and terrestrial forces converge, the planet functions less like a passive backdrop for storms and more like a single, responsive target for the solar system's immense physical power.